So here we go into part 2, the multiplying part. Some of you remember maybe from middle school, whenever you were multiplying and you had something times something, you did FOIL. First, outer, inner, last. Some of you did like a box thing like this. And you had like c squared, 2c negative 3. And some of you have seen what I do in class, which is where I just distribute everything out with little lines, arrows, whatever you want to do. So it really doesn't matter how you distribute, how you multiply. You just have to make sure that everything gets to everything. So on this problem, this has to go to that, and that, and that, and that, and then this part has to go to everything. It gets really, really messy. So once again, you can do FOIL, you can do a box, you can draw lines. Just make sure you're getting everything to everything. Okay, now this problem, I don't have one thing times one thing. I have a binomial times a binomial times a binomial. So I have three things being multiplied together. So if I take a look back and just pretend we have numbers here, 2 times 3 times 4, how would you solve that problem? Well, you would do 2 times 3 is 6, and 6 times 4 is 24. So you start out by doing multiplication between two of them and then multiply by the third thing. So 2 times 3 is 6, 6 times 4 is 24. So back to that, I'm not going to focus on all three things. I'm just going to focus on 2. So I'm going to start by distributing c squared to the second binomial. So c squared times c is c cubed. C squared times negative 3 is going to be negative 3c squared. 2 times c is going to be 2c. And 2 times negative 3 is going to be negative 6. And now that I've multiplied, now that I've done the first part, now I can focus on multiplying this by the last piece, 2c plus 1. So now I'm going to take this 1, 2, 3, 4 terms and multiply by 2c plus 1. So this is where I can draw all the lines. You can draw a box if you want to draw a box. It's really up to you. I'm just going to stick with it with lines for now. So if I'm just drawing lines, I need to make sure that 2c goes to all 4 of these pieces. So 2c times c cubed would be 2c to the 4th power. 2c times negative 3c squared would be negative 6c cubed. 2c times 2c would be 4c squared. And 2c times negative 6 would be negative 12c. But that's just the 2c. Now I have to distribute the 1. So what's 1 times all of this? Well, 1 times c cubed is just c cubed. 1 times negative 3c squared. All of those terms are just going to stay the same because it's a 1. And now that I've distributed everything, I have to do a quick check and see, well, are there any like terms? Are there any parts that can be simplified or anything? Because I'm still adding. 2c to the 4th. Nope. So that just stays 2c to the 4th. Negative 6c cubed can be paired with positive c cubed. Can't talk. So negative 6c cubed plus c cubed would be 5c cubed, negative 5c cubed. Four c squared minus 3c squared is just c squared. And notice that once I'm done with them, I kind of slash them out because it's a lot. There's a lot of work going on. I want to keep it organized. Negative 12c is going to go with positive 2c. Negative 12 plus 2 makes negative 10c. That's out. And then my one constant, negative 6. And notice that you just kind of by default will put it in standard form where it goes high to low exponent-wise. And that's it. So on the next one, I have a binomial times a trinomial. So all I'm doing is just distributing everything out. And if this right here looks too messy for you, what a lot of people like is what's called the box method. So box method says I have 2 terms here and 3 terms here. So I'm going to create a box that's 2 by 3. So I'm going to just create a box that's 2, so 2 rows, 3 columns. And you could flip it. You could have 3 rows, 2 columns. So 2 terms right here, x, top row, -5, bottom row. And then for the 3 terms, I'm just going to space them out. So 4x squared times 9x, or plus 9x, -1. In box method says, remember, I'm multiplying. So to fill in the box, I'm just going to multiply the parts. So to fill in this box, I'm going to do x times 4x squared. Well, what's x times 4x squared? 4x cubed. So that's what goes inside the box. What's 4x squared times -5? That's -20x squared. So that's what goes in that box. And then I'm just filling in an x times 9x is 9x squared. -1 times x makes a -x. 9x times -5 is -45x. And -5 times -1 makes +5. And what's nice about the box method is notice that they kind of line up on the diagonals. It doesn't always work out, but a lot of the times your diagonals will be your like terms. So when I go to simplify this, I get 4x cubed. -20 plus 9 makes -11x squared. -45 minus 1 makes -46x plus 5. So it's kind of line up for me. So basically, the adding and subtracting back to operations, that's just combining like terms. All I was doing was adding what could be combined and what couldn't be combined and subtracting. Multiplying is just like distributive property, but on steroids, 'cause it's a lot to distribute. And that's it. That's all that you're really doing here. Okay, taking a look at this one right here. Lots and lots of distributing before I can even start adding and subtracting. So when I start distributing, 9 times 4x squared is going to be 36x squared. 9 times -7 is -63x. Notice I'm just changing the coefficient. And 9 times 12 is 108. Well, what's going to this trinomial? Not a +12, but a -12. So what's -12 times 3x squared? -36x squared. -12 times a -5 makes that +60x. And a -12 and a -9 makes that a +108. And now that I've distributed combined like terms. So you've seen this before, but now we're just saying operations with polynomials. So 36x squared minus 36x squared, that goes away. -63x plus 60x makes -3x. And 108 and 108 makes 216. That's it. Now, I've asked you to describe this. The degree is just 1. My leading coefficient is -3. There's 2 terms, which means it's a binomial. And I could call this specifically a linear binomial. Linear meaning that the degree was 1. Back up on this problem where I have c to the 4th power, that would be quartic for 4. And because there's so many terms, that would just be a polynomial. And back on this one where you have x cubed, that would be cubic. 4 terms means polynomial. But most of the time, what do we just call these? Polynomials. So taking a look at this one, it's a lot going on. It's 4 times 3 terms times 3 terms. So very similar to this problem right here with all the messiness. This problem right here with all the messiness. But I'm going to kind of clean this up by using the box method. So instead of doing 4 times all of that, and then taking all of that times all of that, I'm going to do the opposite. I'm going to do this times this. I'm going to do the 4 at the end. I'm going to deal with the hard part first. So I have 3 terms and 3 terms. A trinomial and a trinomial means that I don't need a 2 by 3 box, but I need a 3 by 3 box. So I'm going to zoom in so you can see a little bit better. So I need a square, 3 by 3, because I have 3 terms and 3 terms. So I'm going to start filling it in across the bottom. I'm going to do 6x cubed minus 4x squared, and 11. And across the top, 5x squared, 2x, and 9. Notice that negative has to go with the 4x squared. If I forget about that, my whole thing's going to be wrong. So 6x cubed times 5x squared is 30x to the 5th. 5x squared times negative 4x squared is negative 20x to the 4th. 5x squared times 11 becomes 55x squared. And then I'm just filling in every single part. Remember, you multiply to get inside the box. So 2 times 6 is 12. X cubed x is x to the 4th. Negative 8x cubed. 11 times 2 is 22x. And that 9 is just going to change the coefficient. So 9 times 6 is 54x cubed. 9 times negative 4 is negative 36x squared. And 9 times 11 is 99. And what I like so much about the box is that it's already lined up. Not exactly on the diagonals as you saw when I lined up, but for most of them it does. It matches up very nicely along the diagonals. So being really careful here, I'm going to start combining my like terms. So I get 30x to the 5th minus 8x to the 4th. So I add that. I add those. Okay. And then I have 54x cubed minus 8x cubed, which is negative positive 46x cubed. So there's my x cubed. X squared's got a little bit dispersed. So 55x squared minus 36x squared is 22x squared. And then those last ones, plus 22x plus 99. This isn't, my bad, this is 19x squared. That's 22x. 55 minus 36 is 19, not 22. Okay, but I'm not done with this problem because what was out front? A 4. So now that I have this, I have to take every part and multiply it by 4, which luckily is only just changing the coefficients. So 30 times 4 is 120 x to the 5th minus 4 times 8 is 32 x to the 4th plus 184x cubed plus 76x squared plus 88x plus 99 times 4 is 396. And that's it. Lots of work, lots of multiplication, but it doesn't look that crazy because I kept it all in that aligned box. Okay, so now word problem. A triangle has a perimeter of 4x squared plus 5x plus 5. So whoever measured this was super weird. If two of the sides are 2x squared plus 3x plus 6, and one of the sides is x squared plus 3x minus 5, find the third side. So if you're stuck, sketch out a picture. 3 sides. I'm missing one of them. I know what 2 of them are. So one of the sides is 2x squared plus 3x plus 6. The other side's x squared plus 3x minus 5. And I know what the perimeter is. So remember, perimeter means that you add up all the sides. So if I'm missing one, I can still add up what I have, but just take it away from the total. So I need to add up what I have and then subtract it from the total, which is the perimeter. So if I add together what I currently have, combine like terms, 2x squared and x squared makes 3x squared. 3x and 3x makes 6x. And 6 minus 5 is 1. Now I need to take this and subtract that from my total. So my perimeter, my total was 4x squared plus 5x plus 5. And now I'm going to subtract this. And be careful, it's like systems and elimination. 4x squared minus 3x squared is x squared. But the next one's not 11, it's 5 minus 6, which is negative x. And 5 minus 1 makes 4. And that's it. That's your third side. So overall, operations with polynomials is basically just combining like terms and distributive property.